Good afternoon, ladies and gentlemen of YouTube. I'm Chucky2009, and I'm out here with Schlee Tiger.
Schneetiga 77, Peter Zila.
Alright, Zila Industrial Repairs, and today we're going to be talking about MIG welding, specifically how to calculate your wire feed speed, with a machine that instead of having inches a minute on the dial or the display, it has a gauge from like 10 to 100 or 1 through 10, and we're going to be talking about how to determine exactly what voltage you're welding with. So, alright, how are we going to be doing this?
We will need something to measure and the length of the wire and something to measure the voltage that the machine puts out.
Okay.
So, if you have a machine that does not have digital readouts, you pick the numbers on the dial and you measure what wire feed speed you have at each individual number.
Okay.
So, in order to do this, you'll need a stopwatch and you need your welding machine. You dial your welding machine in to 1.
Alright.
And at 1, you let the wire run out of the gun for exactly 6 seconds, which is 1/10 of a minute. Then multiply it by 10. Whatever wire you got, this will give you the inches and a minute.
Yeah, okay.
So, start the clock.
Right.
So, at setting 1, we have 0 inches a minute.
I don't think that worked.
I think it did work.
You think it did work? Here?
I think it did work.
I'll just turn this all the way up, give it a nice pull.
Alright, on 10.
Alright.
You're on 10. On 10.
Yep, look at it go, look at it go, look at it go. Woo! 5. Yep, it's working. Alright. 1 is pretty much 0 on that machine. Actually, I don't think it has a 0, it just has a 1. Alright, well that explains that. Oh, look at that wire. He's got the old-fashioned measuring stick, which isn't quite long enough. Here.
720 inches a minute plus another 10. So we can say about 820 inches a minute on setting number 10.
Alright. So setting 10 gonna be about 820. Cool. Now what advantage is this gonna have as opposed to using like a plain old door chart, for instance?
If you weld critical welds or specialty wire, not just your generic tractor supply, farm and fleet wire, you have, the manufacturer typically makes a book with all his welding consumables for hard facing wire, for stainless wire, for aluminum wire, for flux cord or metal cord wire, gas shielded or self shielded. And these people put a lot of engineering and time into those and find out which wire works best at what speed and what heat. So what they do is they give you a chart for 30 thousandths wire diameter. If you weld it in short circuit transfer, which is the one that sounds like bacon frying, with 100% argon, your contact tip to work distance is supposed to be between 3/8 and 1/2 inch. And at like 300 inches a minute, you're running 22 volts, and this will result in an approximate 130 amps, and you will be melting off 1.6 kilogram or 3.6 pounds of wire per hour. So at this setting, it would take you 3 hours trigger pull time to go through a 10-pound spool.
Awesome. All right, cool. So this is just a way to be a little bit more precise, and apparently, well, we also learned that 1 is 0 on this machine and 10 is, well, a lot of wire. Alright, next up, let's talk about voltage.
Voltage. Every welding machine has voltage settings. If the voltage setting cannot be displayed digitally, you can always measure it with a voltmeter. The way how you do this is you have to tie these 2 prongs into the positive and the negative, into the ground clamp or the gun or any screw where the hot wire for the gun is attached to.
Like the polarity things?
Like the polarity things, yeah.
Alright. In fact, here, let's go ahead and do that. We got the old Hobart 187. As you can see, there's no digital readout and it doesn't tell you voltage. Well, it's got like a 1 to 7 tapped voltage thing.
If you dial the voltmeter to voltage and you put it about right here, direct current voltage, and you switch it on, and then you can tie this right into these two tabs, the positive and the negative.
Okay.
And the moment that you pull the trigger and you start welding, it will read the actual voltage the machine is welding with.
Okay.
Let me show this on this 2400 here.
All right. You want me to shut her off real quick?
No, don't shut her off.
Okay.
we will tie the negative right into the ground clamp, into the copper wire right here, and the positive we can put inside the gun lead actually.
Okay.
The gun lead has in the middle the liner where the steel wire goes through. On the outside there's copper braided wire in it that transports the current to the contact tip here in front that puts the current into the wire.
Okay.
So the best thing is to go right to the copper on the outside. There. And now,
Okay.
why don't you turn the wire speed down to about 5.
All right. Wire feed 5.
And the voltage tabs is on 4 and 4, which means this is heat setting 22 out of 24. But of course we want to know how many volts this is. So what we will do is,
Assuming we don't have this handy dandy readout.
we will,
You want me to hold that? Oh
yeah,
Don't miss.
you just look at the voltmeter as I'm striking the arc.
Okay. You ready?
And you see we're about at 24 and a half volts.
Cool.
So now with these settings, we can adjust the settings, and for different settings, write down the different voltages. So we will know at what voltage tab setting we have what actual voltage there, and we will know at what wire feed speed we will have what wire speed there. So we can dial in every wire, every specialty wire, everything where it's really critical to have the correct amount of heat and wire speed to guarantee like X-ray quality welds.
So you're saying like a door chart like this is fine for some things, but if you want to be a little bit more precise, or maybe your door chart doesn't cover the specific type of wire you're running, like this is all mild steel. If I was putting some stainless wire through it, or
Yep.
like some hard surfacing wire, you know, that's not going to be
Your
covered.
settings would change.
Yeah.
And the most accurate way to look up the settings is go right back to the wire manufacturer. Lincoln, Hobart, ESOP, they all have like books like the size of the Bible here with every electrode that they make, every wire that they make, every TIG rod that they make, and they give you recommendations of how to use it in the appropriate way to get the best results. The door chart will get you close, and you have to tweak a little bit from there. It's a generic chart for a generic wire, but if you're looking to do something more special, something where you want to have the job is more demanding, where the outcome is more critical, you might want to think about going with actual numbers, actually lab tested from real engineers that develop the wire, that make the strength testing, and tell you what would work best to do this.
Lincoln Electric put a lot of time and money and research into figuring out exactly where their stuff runs the best. You know, same with the other manufacturers. That means that you don't have to.
All right,
Cool. Well,
let's
I guess
go
that about
finish the
covers it.
chart up.
All right, awesome. We'll be there in no time. Yeehaw. Thanks for watching, everybody. A big thank you to Peter Zila. And yeah, have a nice night, everybody. Yeehaw.
Yeehaw.